Hello everybody, this is Mr. Avila with another video for our Algebra 2 students called the open box problem, which you studied in our class. Let's go through the situation. Araceli is making an open top box by cutting the squares out of the corners of a piece of paper that is 8 inches by 11 inches and then folding up the sides. So if we have a piece of paper like this and one side is 8, one side is 11, we could cut the corners off, fold up the sides, and create a box. Now, in order to find the volume of that box, we need to multiply length times width times height. To create a function, though, we're going to represent the cut as x, an unknown number, a variable, that's going to represent the cut. And we could create a function to be able to use that in decimals. So then now we are going to represent the length, the width, and the height. The length of the box is going to be this distance from here to here. The width is going to be this distance. And the height is actually going to be produced when we fold up this, each of the flaps up to make the height of the box. Now, the leftover part of each box, for example, here we have the distance of 11. If we start with a distance of 11 from one end of the paper to the other, and we take off x from both sides, then the leftover part, which would be the length of the box, is going to be expressed as 11 minus 2x. Then if we start with a distance of 8 from one end to the other, and I take away 2 x's from both sides, then the width of the box that we create is going to have a width of 8 minus 2x. 8 minus 2x. The height is going to be resulting of the length of the cut, which is x. Doesn't matter where you look, we end up with x. So our volume formula is going to be v of x is equal to 8 minus 2x times 11 minus 2x times x. Length times width times height. Actually, I should have saw length as 11 minus 2x times 8 minus 2x times x. Either way, it's still equivalent. Class, thank you. Hopefully that helps you out. Now we're going to move on to our next part of the question. Now that we have the function, we're going to go ahead and take that function, plug it into decimals in order to find the cut that results in the maximum volume. So we're going to take 8 minus 2x times 11 minus 2x times x, put it into decimals, and you're going to create some kind of graph like this. You're going to see that it's going to go up, hit some maximum point, come back down, and then go back up. And once we do that, you're going to click on this point to find the maximum, the cut that gives us the maximum volume and the maximum volume. And the cut that gives us the maximum volume is when x is 1.525 inches. That is the cut that gives us the maximum volume, and the actual maximum volume is 60.013, which correspond with the points at this relative maximum, 1.525, comma, 60.013. X is the cut that gives us the maximum volume, 60.013. Now, after that, you are asked what is a reasonable domain for this situation. Because since we're cutting corners from a box, we can't cut like 20-inch cut because then there's no paper left. So the graph shows us the possible cuts for the situation. If we were to cut 0 inches, then the volume of the box would be 0. Then as we cut more and more inches, the volume goes up and then it comes down again where it reaches this maximum point. That maximum point that I can cut at is 4. Right? Because the width of the paper is 8 inches, so the most I can cut is 4 inches. So the reasonable cut is between 0 and 4. And that matches up with the other x coordinate here, that would be 4. Within the reasonable domain for what values of x is v of x increasing, so we notice here, between here and the 4, right here at the end of the 4. Where is the values, for what values of x is the function increasing? Well, we're increasing from here all the way to here. To that maximum point, we are increasing. So that would be from 0 to 1.525, which was that x coordinate of the maximum point. From here to here, the graph is increasing. So then where is the graph decreasing? If I ask you within the reasonable domain for what values of x is v of x decreasing, I would say from the 1.525, from right here, all the way to the end, which we found that value to be 4. So from 1.525 all the way to 4. Okay, so we found the areas where this function is increasing and decreasing within the reasonable domain from 0 to 4. That was the open box problem. Hope that helped you out. See you in the next video.